So here's our objective. We want to be able to calculate pH when you're adding strong to a weak. And the A's and the B's are going to be for acids and bases, just to simplify and uh, make it easier to see. All right. Now, typically when we do this, our titrant is our strong acid or base, and our analyte is our weak acid or base. Now, when we do this, we're going to start with some amount of weak acid or weak base. And I made a little graphic for you. If I've got weak acid, what am I going to add to this? I'm going to add a strong base to it. All right. Now, the thing that is interesting about these chemicals is when I add the strong base to the weak acid, all right, I neutralize some of the acid, but I also make the conjugate base of the weak acid in the solution. All right. So it's going to look like this. I'm going to start making some of my my, my conjugate base. And the gray means I'm neutralizing them. All right. Now, this is still going to be an acid. It's still going to have an acidic pH. All right. And what this means is there's still enough weak acid in the solution to determine the pH. Now, as I continue to add the strong base, I'm making more and more of the conjugate base. There's going to become a time where your conjugate base is going to sort of dominate the pH level of the solution, and it's going to become a base. Now, you still will have some of the weak acid in there. However, there's more of the conjugate base, and its equilibrium like dominates. All right. Now, you could make the same kind of infogram for a weak base where you add a strong acid, and it's going to be the flip. It's just like everything would be reversed of this guy. All right. Now, it's a little different for strong acid and a strong base. When you titrate a strong acid and a strong base with either a strong acid or a strong base, or a strong base to strong acid, the graphic is going to look a little different in that you're going to end up neutralizing some of whatever you're adding, all right? And this solution would continue to be a base, all right? Its pH is still going to be a base because I still have some of the strong base in there, even though I do have some that's been neutralized. The only time it becomes an acid is when you've killed, or shouldn't say killed, but neutralized all of the strong acid. You've equal amounts, like 1-to-1 relationship. And then that turns into the pH of the other one. That's like on the other side. All right. The summary or the note, like your conjugate can overpower. You make enough of it and it's going to start determining the pH of the solution. Everybody knows this.